Today we're actually going to talk about solutions and solubility rates. Later on we will discuss about acids and bases. So the first thing that we're going to talk about is what is a solution. So solution would be when you mix something in with something else and it's going to dissolve in there, such as sugar being dissolved in water. That would be a homogeneous mixture, meaning the sugar is actually dissolved into the water and it makes it clear all the way throughout. So it is considered the same throughout from the beginning to the end. Solubility, though, that term means that this substance right here has the ability to have something dissolve in it, the ability of a solute to dissolve in a solvent. And we're going to define what those two terms are in the next slide. So an example of solubility is water. You can take sugar or you can take salt, two common items that are out there in your pantry. And you can actually pour that into water and stir it and cause it to actually dissolve in there. Now, the parts of the solution that I was saying, these are the two parts. You got the solute and you got a solvent. Now, the solute is the part that actually is being dissolved. So an example of things that dissolve in there could be sugar, salt, and I like this one, the hot chocolate mix. You get the Swiss Mix instant hot cocoa mix, and that powder right there, you mix it with water, stir it up in the hot water because you want hot cocoa. It's getting chilly out there, and then that cocoa mix will actually dissolve into the liquid. Okay, the solvent is that part that actually does the dissolving, such as the water. But you can have another solution that could not be necessarily water. It could be alcohol-based, like your permanent markers. They're alcohol-based, okay? And so let's say you go somewhere and they put an X on your hand to mark that you've gone in there. Well, that if you use water, you might be able to get it off, but to get it off a lot quicker, use your alcohol on a cotton ball, get it saturated, and rub it over the parts, over that marked part on your hand. Bam, it is gone. Okay, so that solvent would actually be the part that does the dissolving. Water, most things are water-based out there, like your Kool-Aids, a lot of your soft drinks, again, the sugar and water, salt and water, ocean water. The water is your universal solvent there. Now, there are factors that affect it. The first one up here is polarity. Polarity affects it, whether or not substances can stick or not stick, okay, on there. So polarity is one item. Don't really need to know too much about that one. But another one that we're going to focus more on is temperature. And temperature basically, if you increase the temperature, let's say I got a pot of boiling water or water and I put it on the stove and I get it going a lot hotter, increase the temperature, then I can get more sugar to actually dissolve in it. Think about this. I want to sweeten my tea. I get hot tea, put it in a container, add sugar to it. Bam, it's going to dissolve just like that. But if I take that same sugar and put it in cold water, it's just not going to dissolve as quick. It will, but over time, it's going to take a little bit there. It's not going to dissolve as fast as if you put it in hot water. So if you increase temperature, you also increase the ability for a solute to dissolve in the solvent, okay? Now, there are different levels of solubility that we have of your solutions, and one of them is called unsaturated. And that's like going to Bojangles, getting your iced tea, an unsweet iced tea. You drink it, and you're like, oh, this is just not sweet enough for me. So I'm going to add just a little bit of sugar in there just to give me just a little bit of flavor. And unsaturated means I got very little solute holding little solute in a lot of solvent, meaning a lot of water. So the unsaturated, if you look at the diagram here, just a few particles of that sugar in that big tall glass of water. Okay, now saturated, like we've had a lot of rain. Thank goodness the sun is shining and we don't have as much rain. But when it was raining and raining and raining, you'd go out there out on the grass or walking around and just the ground was squish, 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 squish as you're walking into it. That means that the ground was saturated. That means it's holding as much water as it can into that soil. So it's holding as much solute in at a given temperature. So if I go back to that Bojangles iced tea, that sweet iced tea, it's as sweet as it can be. It's holding as much sugar as it can. Okay, so that's saturated. Okay. And you also heard the phrase, like I said, with the ground being saturated with water. It's holding as much as it can at that given temperature. Now, supersaturated is the most unstable, okay? And it's going to hold more solute, more in there at a higher temperature. So if I increase that temperature, I can get more sugar into that Bojangles tea. But if it's at room temperature, it can only hold a certain amount. But if I heat it up, more of it can be dissolved in there. So you might ask, well, how does this relate? What does this mean with solutions? When we look at graphs and we determine the solubility rates and things like that, we determine where they are on graphs. And we're going to look at that in a minute. Now, there is some other neat factors. One is called, with what do you do about solutions that can produce electricity? Maybe in your elementary and middle school experiences, you may have seen it where you could take a potato, take some pennies, hook it up with a wire and a light bulb, and you can actually light it up. And there's certain materials like lemons and oranges, citric fruits and things like that, that actually can produce electricity. So, an example of this one would be an electrolyte. And look at the word right there, electro, like electricity. Electrolyte means you've got a solution that can produce electricity. So an example of that would be salt mixed in with water. Now a non-electrolyte, and let me get my pen out here. The non meaning not, cannot, okay, for non, not. It's a solution that can't produce electricity. So actually sugar mixed in with water is a non-electrolyte. Salt does produce electricity. So that one would be an electrolyte solution. Now we have another type of ways dealing and explaining solutions, and that is with them being concentrated versus diluted. Okay, so I get that Bojangles tea. It's a hot day. I go get it and I'm drinking it. Ooh, it's really sweet and it's good. But then I let it sit outside, and of course it's a hot day, and that ice is going to melt. And as that ice melts, it's adding more and more water into that tea, and it's starting to dilute it. So right here I got a lot of, let's say, food coloring in here, a good amount here, a little less, and this might be less than a drop in. And so this could also mean a lot of sugar to little sugar. So when I look at the comparison here, a concentrated solution means it's very strong. Like a very strong acid means it's very concentrated with the acid, very little water. Whereas it's diluted, meaning I'm watering it down, I'm weakening it by adding more and more water in there to that product. And there are different ways that I can cause that solute to dissolve in a solvent. Different ways I can get that sugar to go into the water. And these are different ways I can speed it up. And of course, the first one you can see with the chef here, he is stirring it right there. So that's one. Another one is heating it. So you can see over the flames, he's got a double whammy here where he's stirring, but he's also heating it. And the last one is powdering. If I take a sugar cube, which you can find these, now it's hard to find sugar cubes, but you can go to Harris Teeter and they do have the Dixie Crystal sugar cubes. Back in the day, in the restaurants, they would have those sugar cubes, okay, and have those out on the counter, and you would pick one up and place that in your coffee, but it would take a little bit of time to dissolve it. A faster, more effective way is to actually take the granulated sugar, meaning it's all loose like this picture right over here, and more of it is exposed. The surface area to each of the particles is exposed, and therefore it can dissolve at a faster rate than an actual sugar cube. Okay, and those are 3 ways you can increase the rate of a solution to get the solute to dissolve in the solvent: stirring, heating, and then powdering. Okay, now there is a solubility curves, and these are graphs that show how temperature affects the solubility rates of that solute to dissolve in the solvent. So we're going to look at these. This is the actual solubility curve, and I'm going to go back and forth with the question that we have to date on here. Okay? So the first question, and these are also on your graphic organizer, they say what compounds shows a decrease in the solubility from 0 to 100 degrees Celsius. So I'm going to go back here and let me get my pen in place. And it's showing the temperature going from 100 or 0 to 100 going in this direction. I want to see a decrease. And so a decrease means I want to see a downward shape in my line. And when I look at this, reading from going from left to right, and again, you got to look from left to right, there are 2 lines that are actually going down. It's this line right here, and then this one right here. But we want the most. And the most would be actually this one right here, and you would write NH3 as your answer. Okay? NH3 shows a decrease in solubility. So on that one, the one I showed you has a definite decrease there. Now, question number 2 asks, which salt is most soluble at 10 degrees Celsius? All right, now I'm going to go back. Let me get my pen going. At 10 degrees Celsius, and here's my temperature at 10 degrees. So I'm going to look at this line right here. I'm going to go all the way up. And they want the most soluble. Most soluble means go for the highest. Go for the highest. And the highest one on that one would be Ki. Okay? If it's the least, then I'm going to choose this point and try to locate it. But the highest would be the tallest up there. Okay? Now the next one, which salt is least soluble? Least soluble at 20 degrees. At 20 degrees, let me get my pen on. Oops, let me go back. Let me get my pen on. Here we go. 20 degrees right here. Least soluble, you come up in the first line you hit, right there it is. So that answer would be KClO3. Okay? Next one. Which salt shows the least change? The least change means it's going to be kind of like a flat line. A flat line. Okay, so I'm going to go back, get my pen, and I want to know which line looks the most like a flat line. Okay? And when I come up here, the one that looks the most like a flat line, I can see it right here, this line right in here, and it's NaCl. There you go. It has the flattest line. Okay, this one. How many grams of potassium chloride, KCl, is dissolved at 80 degrees Celsius? 80 degrees Celsius, so let me get my pen going. 80 degrees Celsius, we want to go up to KCl. Going to go to that line right here. And at this point, we want to know how many grams of that solute. So what I do is I have to go all the way over here, and the amount of grams is 50. Okay? Now remember, this is per 100, and that's going to be crucial for the next couple of questions. But that's how we read it. You go up to the temperature 80, follow till you find the KCl line, follow it over, and that gives you the amount of grams that was dissolved. Okay, now this one right here at 50 degrees Celsius, how much potassium chlorate can be dissolved in 300? No, look at that. That is 300 grams, okay? 300 grams. Whoops. Let me go back to the PowerPoint right here. So 300 grams, let me go forward again. 50 degrees Celsius, KClO3 at 300 grams, okay? So 50 degrees, let me get my pen, okay? And I'm going to go up to KClO3. KClO3, right here it is, at this point, right here. I'm going to go over, and I see 20. But the 20 grams is actually at 100 grams. But we want it being dissolved in 300 grams of water. That's a lot more water. That's 3 times as much. So what you do is you take that 20 and you're going to multiply it times 3 because it's 3 times as much. So 3 times 20 would be 60 grams. Okay, so I'm tripling the 20. Okay? Now the last one, at 30 degrees Celsius, 90 grams of sodium nitrate is dissolved in 100 grams of water. Is this solution saturated, unsaturated, or supersaturated? So we're going to plot this point where it is on the graph. At 30 degrees Celsius, 90 grams of NaNO3. Okay, 30 degrees at 90 grams, NaNO3. So let's go back. 30 degrees, so let me get my pen. Oops, let me go back. Okay, let me get my pen going. 30 degrees, okay, 90 grams, where the two intersect, and I'm going to draw that point. Here's 30, and here's the point. Now this point, here is the line NaNO3. Now, is this line below, on, or above? If it is below, it is unsaturated. If it is on the line, this line, it is saturated. And if it is above the line, it is supersaturated. So this point right here, when I graphed it, it is below. So therefore, it would be unsaturated. Okay? If you have any questions, please see your teacher. And thank you very much.